In today's lesson, we are going to be looking at angle rules and properties. Some of these you may have already seen before, some of them you may have not, but it's good review either way for looking at angles. So just a little bit of review of the different types of angles. We have a straight angle, which forms 180 degrees or forms a straight line. We have a reflex angle, which is greater than 180 but less than 360. We have a full angle, which is 360 degrees or a full circle. We have an acute angle, which is less than 90 degrees. We have an obtuse angle, which is greater than 90, but less than 180. And then we have a right angle, which usually is denoted or marked by a square to represent the angle, and that is 90 degrees exactly. So along with the different types of angles, there are some rules to look at. So the first rule is looking at a straight line. And when we're dealing with a straight line, the sum of the angles that form a straight line have to add to 180, which makes sense because we just mentioned that a straight line has an angle of 180 degrees. So any angles that form a straight line have to add up to 180. When we're going around a point, so the sum of angles that form around a point or a full turn have to add to 360 degrees. Again, this makes sense because all these angles, when you put them together, they form a full circle. And as we mentioned, a full circle or a full angle is 360 degrees. So all the different components have to add to 360. When we're dealing with opposite angles, and these are angles that are opposite of each other at a specific vertex. So if we have two lines and they cross at a specific point, the angles that are opposite of each other from that point are equal. So this orange angle or these two orange angles are equal in measure, and same with these two purple angles. They're equal in measure as well. Rule number 4, parallel angle rules. So when we're dealing with parallel angles or a line that intersects a pair of parallel lines, as we can see here, we have a set of parallel lines or a pair of parallel lines, and they are intersected by another line. We have some specific rules that apply. The corresponding angle rules, or in other words, you may see it as what you call an F pattern. So in this case, B and F are equal, angle B and F. And if I draw the line, or if I draw an F made out of the lines, the parallel lines and the intersecting line, I can see that these two angles are equal. I could do the same thing in different directions, and I would see that D and H are equal. Or I could flip it, and I'd see that G and C are equal. Or even flipped and reversed. And then E and A are equal. So if we draw, that's what we consider an F pattern, and those angles are equal. Alternate angles, we can see here E and D, or in other words, you may have seen it as the Z pattern. So if we form a Z in any shape or form, the two angles that are a result of that, for example, if we draw a Z the normal way, C and F are equal. Or if I draw the Z backwards, D and E are equal. So in the alternate angles, or the Z pattern, the angles are equal. Supplementary angles, in this case D and F, supplementary angles, or in other words, you might see it as the C pattern, because again, as you might have guessed, that the lines of those angles form a C. So we kind of see a C here. These two angles, they aren't equal, but they add to 180. So they add to 180, which is what this kind of Greek letter is referring to. Just means the sum is equal to 180, or these two angles equal 180 when you add them. Again, you can kind of reverse the C as well, and the same rule applies. These two angles add to 180 degrees. Rule number 5, when we're dealing with triangles, this is just some characteristics of triangles we may want to be careful or mindful of. So in equilateral triangles, all sides are equal, as well as all angles. So all angles are equal in an equilateral triangle. In an isosceles triangle, the two base angles are equal. As you can see in the diagram down here, this is what we're referring to when we're talking about the two base angles. In a scalene triangle, all angles are different, and all angles in a triangle have to add up to 180. So again, we may have, that one should be more common. So all angles add to 180, regardless of the type of triangle. So if you go to the course content, you'll find an angle theorem matchup. So just take some time, but you're basically matching 4 squares together, a title, a description, a diagram, and a solution for the different theorems that we looked at. So again, take some time to do that. If you're just watching the video, we will go through and we'll look at the solutions. Here are some hints as well to help you, just kind of a refresher again of the different types of angles that we talked about, or the parallel angle rules, the Z, the F, and the C pattern. But looking at the solutions, so the sum of angles in a triangle, again, we mentioned that they have to add up to 180. We have an example where the solution has to be 70. In the isosceles angle theorem, the opposite angles, or the base angles, as we mentioned, the base angles are equal. So in this case, the missing angle is 74. Supplementary angle theorem, we didn't quite mention this by name, but this is just an example of the straight line. You can think of S as in straight. So straight line, or the straight angles. So angles in a straight line have to add to 180 degrees. So all 3 of these angles have to add to 180. So that means the missing angle has to be 105. Opposite angle theorem we mentioned, right? Opposite angles are equal. So in this case, the missing one is 30. Parallel line theorem, looking specifically at alternate angles. So the alternate angles, this is the Z pattern, which means that corresponding angles are equal, or the alternate angles are equal. Corresponding angles in the parallel line theorem, this is our F pattern. Again, the corresponding angles are equal. And the co-interior angles, or the supplementary angles, as we mentioned previously, the 2 angles form a C pattern, and they have to add to 180 degrees. So just as an example, let's find the measure of the missing angles. So again, we see our parallel lines here, and we see our line that is intersecting them or crossing them. So we're going to use or try to look for those different letter patterns, the Z, C, and F pattern. So if we go through, we can see a Z pattern here. It is backwards, but again, that still works. That means that D has to be 75 degrees. Now we could use opposite angle theorem because we have an angle opposite another angle where 2 lines are crossing. So F is 75 degrees. You may have also said that it's the F pattern and that these 2 angles, 75 and F, have to equal. That would work as well. B, again, opposite angle theorem. You can say that B has to be 75 degrees. For A, you would use the straight line theorem or the straight angle idea. These 2 lines or angles make up a 90 or a straight line. So A plus 75 has to equal 180. So in this case, A is 105. And again, you could fill in the other missing angles if you wanted to as well, based off of that. But based on all the letters that I have that I need to find, I've completed this example. Same idea for the next one, right? We could use the F pattern for some of these, even though if it's sideways. We see the F pattern here. So again, V would be 108. Using the opposite angle theorem, we know that S has to be 108. We can use the C pattern and say that V and R have to add to 180. So in this case, R would have to be 72 degrees. Opposite angle theorem for P is 72 degrees as well. And again, you could use the F pattern for U, or the straight angle theorem, or supplementary angles, to figure out that U has to be 72 degrees. So again, different ways that you can figure it out, different kind of patterns that you can use, but these are solutions you should be getting. Moving on from kind of straight lines, we're going to look at some triangle rules. So a line segment that joins the midpoints of two sides of a triangle. So if D and E are our midpoints, or halfway through, they split the two side lengths in half. This line is parallel to the base of the other line, or BC. And this line that we create by joining the midpoints is also half as long as the base of the triangle. So BC is equal to 2 times, or is equal to twice the length of DE. So that's what these two letters represent. They're representing the length. So the length of BC is equal to 2 times the length of DE, or basically saying that DE is half the length of BC. Another triangle rule, if we go and we take that midpoint, or that line formed by the midpoint D and E that we kind of just created, the height of the new triangle that's formed. So this new triangle here, this new triangle that's formed, kind of highlighted in yellow, this height, AF, I'm drawing in red, that is half the height of the original triangle. So AF is half the height of the original triangle, which is all of this. So that means that AF is half the height of AG, or AG is twice as long as AF when we form or create the two triangles from that midpoint DE that we created, that line segment. And then finally, the medians, which is basically a line going from a vertex to a midpoint of a triangle, bisects its area. So if we go to any vertex and we draw a line or a median, or a line from one point, or from that vertex to the midpoint of the other side, so we see from Z to midpoint A, that line that we're drawing is our median. That basically cuts our area in half. So the area of ZYA is equal to the area of ZAX. Moving on from triangle rules, we're going to go back to angles, but look at specifically angles in a triangle. So the first one, we're going to be looking at the exterior angles. So the exterior angles in a triangle, the first property is that the sum of them have to equal 360. So this is essentially saying, if I look, I'm drawing all the interior angles right now. Those are the ones that we've kind of been familiar with before. But if we look at the exterior ones, I'm going to draw those in red. So there's the angles that form with the outside, or with those interior angles, or kind of the complements to them. Those exterior angles all add up to 360 degrees. So all those exterior angles add up to 360 degrees. That's the first property. The second property is that for any exterior angle, in this case Z, it is going to be the sum of the opposite two interior angles, so X and Y. So in this case, X and Y is going to equal what Z is. So if we go back up to here and we look at some of the examples. So if I look at y down in the bottom left, that means these two angles in green, if I were to add them up, they would equal angle y. Same thing for angle z. These two angles in yellow or gold or whatever you call it, the sum of those two angles would equal angle z. And for x, these two angles in blue, the sum of those two angles would equal angle x. So again, that's just some more examples of what we're referring to when looking at property 2, where the two interior or the opposite interior angles equal, or the sum of the opposite interior angles, sorry, equal the exterior angle. So for example, let's determine the measure of the third missing exterior angle. We have two of them, 120, 140. We're missing that third one. In this case, the two angles, or all three angles, sorry, have to equal 360 degrees. So I can take 360 minus 120 minus 140, and I get 100 degrees. So that means that angle x is 100 degrees. Because again, the property is stating that all three of those angles have to add to 360 degrees. For the next one, determining the measure of angle z, again, referring to property number 2, it said that angle z, or this exterior angle, is equal to the sum of the two opposite interior angles. So if I add 70 and 40, get 110, that's my angle z. Now you could do it another way as well. You could figure out, okay, well, what is this missing angle? And interior angles, all angles have to add to 180. So 180 minus 70 minus 40 would equal 70. So this is 70 degrees here. And then we know from straight angles that this angle and z have to form 180 or equal 180. So in this case, z would have to be 110. So there's different ways of working around it. You may not just have to use that exterior angle property if you forget it. Looking at quadrilaterals, so interior angles in a quadrilateral is different from the interior angles in a triangle. A triangle, all the angles added to 180. In a quadrilateral, which could be a rectangle, a square, a parallelogram, or just any sort of four-sided enclosed figure, the interior angles have to add to 360 degrees. The exterior angles, they also add to 360 degrees. So this property is the same between quadrilaterals and triangles. And if you look at further shapes, you'll find that the exterior angles of any sided figure are always going to add up to 360 degrees, not just triangles and quadrilaterals. Interior angles is different. That's something that doesn't stay the same for shapes, but exterior angles is always going to be 360, regardless of how many sides the shape has. But in this case, we're only going to be really looking at triangles and squares, or quadrilaterals. Either way, 360 degrees. So just a couple of examples, again, just kind of going over those properties. So again, we have 3 out of 4 angles in our quadrilateral. All 4 angles have to add to 360 degrees. So 360 minus 85 minus 60 minus 135. This will give us our fourth angle, which in this case would be 80 degrees. So x, or our missing angle, is 80 degrees. For B, or the next example, again, same idea. It's actually the same type of calculation because we're dealing with 360 degrees, again, for the exterior angles. So 360 minus 95 minus 105 minus 50 works out to 110 degrees. So that means that this exterior angle is 110 degrees. So Again, from this lesson, it was just hopefully a review of some of the angle properties that you may come across when dealing with angle measurements or dealing with certain shapes like triangles and quadrilaterals, or just dealing with lines in general. So just some of the rules and properties that we can use to help us find missing angles.